One of the keys to understanding the Big Bang Theory is to first understand the forces in nature and how they might have been unified in the very early universe. We'll discuss these fundamental forces in this video. According to our modern understanding of physics, everything that happens in the universe today is governed by just four fundamental forces: gravity, electromagnetism, the strong force, and the weak force. Let's briefly consider the roles of each. Gravity is the most familiar of the four forces because it explains everything from why we remain on Earth's surface to the collisions that can occur between galaxies. However, on a per-particle basis, gravity is by far the weakest of the four forces, as you can recognize by thinking about a pair of subatomic particles. For example, consider two protons. Both have mass, so the universal law of gravitation tells us that there should be a gravitational force acting to pull them together. But protons also carry a positive electric charge, and the electromagnetic force repels them much more strongly than gravity attracts them. That is why all interactions between the charged particles that make up atoms and molecules, which means virtually all chemical and biological reactions, are governed almost entirely by the electromagnetic force. Indeed, the only thing that prevents electromagnetism from always dominating gravity is that there are also negatively charged particles, like electrons, and the strong attraction between opposite charges ensures that large masses are electrically neutral overall. In contrast, more mass always means more gravity, allowing gravity to dominate for large objects like planets, stars, and galaxies. We rarely notice the two remaining forces in our everyday lives because they act only over extremely short distances, like those within atomic nuclei, but they are very important. For example, the strong force is the force that binds atomic nuclei together because it is strong enough to overcome the electromagnetic repulsion that would otherwise break apart any nucleus with more than one proton. It's also responsible for holding individual protons and neutrons together, because these particles are made of smaller particles called quarks. The weak force plays a crucial role in both fission and fusion, and is also the only force besides gravity that affects weakly interacting particles, such as neutrinos. The four forces seem quite distinct in today's universe, but current models of physics predict that they are actually manifestations of a smaller number of more fundamental forces. As an analogy, consider ice, liquid water, and water vapor. These three substances seem quite different in appearance and behavior, but we know that they are all made up of the same underlying molecule, H2O. In a similar way, experiments and models indicate that the four forces will lose their separate identities under conditions of extremely high energy or temperature, like those that prevailed in the very early universe. This graph shows temperature increasing to the right. Because the universe must have been hotter at earlier times, higher temperature corresponds to times closer to the Big Bang. Notice that these times, shown in seconds, are extremely small, indicating that most of this graph shows temperatures that prevailed only within the first tiny fraction of a second after the Big Bang. The vertical axis shows the relative strength of forces. Note that at low temperatures, like those that exist in the universe as a whole today, the four forces are distinct, and gravity is by far the weakest. However, as we look to the higher temperatures that prevailed at earlier times, the forces begin to lose their separate identities. To be sure you understand the idea, try this question. Which of the four forces that exist today were merged together in what scientists call the gut force? Was it the strong and weak forces only? The strong, weak, and electromagnetic forces? All four of the forces that exist today? Or electromagnetism and the weak force only? The answer is B, the strong, weak, and electromagnetic forces. To see this, notice that the electromagnetic and weak forces merged to become the electroweak force here, at temperatures predicted to have occurred when the universe was about 10 to the minus 10th seconds old. The gut force then comes into play when the electroweak and strong forces merge at even higher temperatures, representing an even earlier time in the history of the universe. Experiments performed with particle accelerators have confirmed the prediction that the weak and electromagnetic forces unify to become the electroweak force, and at least some evidence suggests that the gut force really exists at very high temperatures, though we cannot test such temperatures directly. What occurs at the very highest temperatures is more speculative, but as you can see here, scientists suspect that in the first instant after the Big Bang, all four forces were unified into a single superforce. If so, that earliest moment was a time of ultimate simplicity in the universe.